Okay, so yesterday we started talking about simplifying trig identities using all that reference sheet, right? Which had the reciprocal functions, even odd functions, Pythagorean identities, and cofunctions. Yep. And the ones, I would say the ones that we hadn't covered so far were the sine squared plus cosine squared equals 1. And then tangent squared plus 1 equals cotangent, equals secant squared. And then 1 plus cosecant squared equals cotangent. Other way around. All right, so the first one says, simplify the given expression, secant of x minus 1 times secant of x plus 1. What would you do there? Foil them out, and I end up with secant squared x plus secant x minus secant x minus 1. These cancel, and I get secant squared x minus 1. If you go back to what is over here, if I subtract the 1 from the right and the left-hand side, what's left? Just tangent squared. Number 2, simplify the given expression. Again, you can distribute here, or you can do what? What is 1 minus sine squared? Cosine squared. So I'd get secant squared x times cosine squared x. And then secant can be rewritten as what? 1 over cosine times cosine. These cancel, and I get just 1. If you had distributed that in, you would have had to, it gets a little bit more complicated, but secant squared x minus secant squared x times sine squared x. You can make that 1 over cosine squared x minus, this would be sine squared x over cosine squared x. Combine them into 1, I get 1 minus sine squared x over cosine squared x. 1 minus sine is cosine. And I still get 1. So you could do it either way. Obviously the one on the right is a little less complicated, but they're both right. Number 3, what's one way to do it? Get the same denominator. So you did secant x times cotangent x minus tangent x times cosine x all over cosine x cotangent x, like that? Yeah. Then where'd you go from there? Just there. Okay. Where could you go from there?
Could you make secant and cotangent different?
So I would write them as the reciprocal functions, like 1 over cosine x times sine, nope, cosine over sine x minus sine over cosine times cosine all over cosine x cotangent x. I could do that, right? Then I can combine these two and these two, so I get cosine x over actually no, sorry, they cancel. Make life easier. Cancels. I'd get 1 over sine of x minus, these cancel, sine of x over, I could rewrite this as cosine of x times cosine over sine. So for the top, I'd have to get them to have the same denominator. This would be 1 minus, I'd have to multiply by sine squared x over sine all over cosine squared x over sine. Keep change flip. And I get 1 minus sine of x, sine squared of x over cosine squared of x. What's 1 minus sine squared of x? Cosine. Just 1. We do it differently. Remember that shortcut I taught you yesterday? What did I tell you happens when you move from the bottom to the top? Somebody heard me, right? It becomes its reciprocal function, yes? So if I move cosine to the top, what does it become? What's the reciprocal of cosine? Secant. So this would be secant x times secant x. Minus, if I bring cotangent to the top, what does it become? Tangent. Tangent x times tangent x. So this is secant squared x minus tangent squared x. 2 squareds tells me go back to my Pythagorean identities. And if I have secant minus tangent, what's on the other side of my equal sign? 1. Yep. They're called shortcuts for a reason, right? Sometimes they're super helpful. Same credit would have been given to both answers, okay? But one of them you would have spent a lot longer on, maybe gotten a little frustrated. So just be careful. A lot more opportunities for mistakes. Questions on the warm-up? So 5, what did I tell you, A and C were switched, right? These two are switched. 5 said cotangent squared x minus cosecant squared x. So if you go back to your reciprocal functions, right? If I go back to these, there's one with cotangent and cosecant. Okay, if it's cotangent minus cosecant, that means it's 1 plus cotangent squared. I subtract the cosecant, and then I have to subtract the 1. So cotangent squared minus cosecant squared would equal -1. That's that one. And then the other one, sine of negative x over cosine of negative x. Remember that if they are even, if it's an even function, the sign literally goes away. If it's an odd function, it becomes part of the front. So sine is an odd function. This would be the same thing as negative sine of x. And cosine is an even function. That would be the same thing as cosine of x. There's one negative there, which means this is negative tangent of x, which was A. Okay, this is 11. So the numbers in red changed depending on who it is, but the process is exactly the same. So this is 7 cosine of x over 1 plus sine of x plus 7 plus 7 sine of x over cosine. Two different functions, two different fractions. So I need to give them a like denominator. So I'm going to multiply this one times cosine of x and this one times 1 plus sine of x. So I get 7 cosine of x times cosine of x, which is 7 cosine squared of x. And then I get 7 plus 7 sine of x times 1 plus sine of x. And that has to get FOILed. 7 plus 7 sine of x plus 7 sine of x plus 7 sine squared x. 7 plus 14 sine x plus 7 sine squared x. So this is the top of the left one and this is the top of the right one, which means I'm going to add them together and put them all over 1 plus sine of x times cosine of x. So from there, because you have 1, you could take a 7 out of all the ones on the top. I could say 7 cosine squared x plus 1 plus 2 sine x plus sine squared x over 1 plus sine x cosine. What in the numerator, what else can you do? What is cosine plus sine? 1. So I can change that to be 1. And now I have 7. 1 plus 1, so 2 plus 2 sine x over 1 plus sine x times cosine x. That means I can take out another number because I can come bring out 2. So this is 14 times 1 plus sine x over 1 plus sine x over cosine x. These cancel and I get 14 over cosine x. Cosine's going to come to the top as its reciprocal function, which is secant. So if your numbers were different, like the other one, I think that was yours, like Valentina, right? It was 4. Like everything's exactly the same except for the numbers that are there. It should have been 8 because you would have had double it. Okay, this one says 4 cotangent of pi over 2 minus x times cosine. These are my cofunctions. So remember, cotangent goes with which one? Tangent. So this becomes 4 times the tangent of x times the cosine of x. Tangent is sine of x over cosine of x times cosine of x. These cancel, and I get 4 times the sine of x. So whoever's this was, you just had to keep going based on this. You couldn't stop there. You can keep going. This one, sine of x times cotangent of x plus tangent of x. So you can distribute this in. I could say sine of x times cotangent of x plus sine of x times tangent of x. This becomes sine of x times cosine over sine plus sine of x times sine over cosine. These cancel, and I get cosine of x plus sine squared of x over cosine of x. Still not simplified enough. I want to put this over 1. I want to give it the same denominator. So I'm going to multiply both the top and the bottom by cosine, and I get cosine squared of x plus sine squared of x all over cosine. Cosine plus sine is 1. This is 1 over cosine, which becomes secant. Questions on that one? Factor the expression and use the fundamental identities to simplify. So this time you had 4 terms, okay? You can actually say that a equals secant, and I could say this is 4a to the third minus 4a squared minus 4a plus 4. And then I would factor by grouping. So from the left set of parentheses, I could take out a 4a squared, and I'd get a minus 1. From the right set of parentheses, I could take out a negative 4, and I'd get a minus 1. Then a minus 1s are the same. That's going to come out 4a squared minus 4. And I could factor that even further. I could say a minus 1, and then 2a plus 1 to a minus 1. No, minus 2. Okay? Or I could have taken out the 4 from there. So I could have said a minus 1 times 4 times a squared minus 1. And that's still a minus 1, 4, a plus 1, a minus 1. Either way, you could either take out the 2, or you could take out the 2 twice, or take out 1, 4. So because this is a was secant, this becomes 4 secant x minus 1, secant x plus 1, secant x minus 1. And actually, that gets simplified, right? That should be 4 secant squared x minus 1 times secant x minus 1. This is tangent. Because of your reciprocal identity. I mean, your Pythagorean identity. So just be careful, because if you don't keep the secant in it, you won't catch the Pythagorean one until you get to the bottom. You'd have to FOIL at least 2 of them back out. You'd have to FOIL this back out. If you keep the secant in it, you might have caught it earlier. But you still got to check for those things. Questions on that one? Yep.
I have a question for the last one.
Okay. All right. 5.2 is called verifying trig identities. So the good news is if you did well yesterday, it should get even easier today. The bad news is if you hated yesterday, you're probably going to hate today. And this is 2/3 of your quiz, okay? So I think it gets easier when you get to verifying, because verifying actually gives you a stopping point. There's an equals something. So you know when to stop with these, because your entire goal is to get the left side of the equation to equal the right side of the equation. Same exact reference sheet. You need reciprocal identities, Pythagorean identities, even and odd, and cofunctions. They're all going to come from the same piece of information. And then here's some strategies. So this is guidelines from your book. Work with each side of the equation independently of the other side. So usually you can work one side down to hit the other side. Not always, though. Sometimes you got to work both sides. Sometimes you can even move things from one side to the other. It doesn't matter, as long as you're at the end getting the left side to equal the right side, okay? The second thing says analyze the identity and look for opportunities to apply the fundamental identities. So everything that we did yesterday, you're going to do again. If you see reciprocal functions, you're going to replace it. If you see Pythagorean identities, you're going to simplify them, all that good stuff. Try using one or more of the following techniques. So usually, you're rewriting the more complicated side in terms of sine and cosine. If I have something over here equals sine of x, obviously I'm not working that sine of x. I don't want to make it like 1 over cosecant, right? I want to take the other side and work with that side. Factor out greatest common factor. So look for things that you can take out, just like we used to do with factoring when it was trinomial or binomial. Separate a single term quotient into 2 terms. So yesterday at the end of the class we talked about this. Sometimes you've got a fraction in which you have multiple terms in the numerator, and it might be easier to split these into 2. Just make sure you give them both the same denominator, whether it's addition or subtraction. Or vice versa, combine fractional expressions. So if I had 2 separate expressions, sometimes I've got to combine them into 1 to simplify them. And sometimes you got to find the least common denominator to do that. And then the last one says multiply the numerator and the denominator by a binomial factor that appears in the other side, God bless you, of the identity. So if I had something like sine over tangent x here, and it made sense to multiply by tangent over here, you can do that. It's just like a regular equation. It would cancel from here and it would move it to the other side. Here's the biggest thing. 1, don't allow yourself to get frustrated. Sometimes you're going to have to stop and start it all over again. Sometimes you went in a direction that makes sense by the rules of the fundamental identities, but it is not right, and you have to start all over again, okay? It's bound to happen at least once. So it's like it says, creative puzzle solvers, no strategies leading to dead ends, often provide good problem-solving ideas. These are kind of like puzzles. You know what it's supposed to look like at the end. You just got to get there. It's like a geometry proof, okay? Sometimes it's not in the process, and sometimes you got to start and stop over. All right, so this says verify the identity. Cotangent squared plus cosine squared plus sine squared equals cosecant squared. Obviously, what side of this should you be working with? The left, okay? So I know I'm done when I hit cosecant squared x. What's on the left that you can do?
Cosine and sine could be 1.
Good. Cosine squared plus sine squared can be 1. And then I get cotangent squared x plus 1 equals cosecant squared x. What do I do with cotangent squared x plus 1?
Make it cosecant.
That's your Pythagorean identity, right? And that equals cosecant squared x. Your last step is always what the left side equals the right side, okay? Don't stop here. You need to get into the last step. Don't skip steps because your work is your credit here. All right, tangent squared minus sine squared equals tangent squared times sine squared. So what side is more complicated? What's harder to do, multiply 2 things or add or subtract 2 things? When they have denominators. The adding and subtracting, right? So I'm going to try that side. It may not always work, but I'm going to try that side. So what can I do with tangent squared x? First of all, they're both squared, so I would look at my Pythagorean identities first. Is there a Pythagorean identity with sine and tangent? No. So what can I rewrite tangent as? Sine squared x over cosine squared x. Now what? Good. I need to give them the same denominator, so I'm going to multiply both the top and the bottom by cosine squared. And I get sine squared x minus sine x squared cosine squared x all over cosine squared x. Now what?
Factor out the sine x.
I can take out a sine squared. Now what?
Take the 1 minus cos x squared sin x squared.
Good. This is going to be a Pythagorean identity, right? This would be sine squared x. So sine squared x times sine squared x over cosine squared x. Now what? keep your goal in mind, right? I want to go to here. Ian. I can separate out the sine and the cosine, right? Sine squared x over cosine squared x times sine squared x. And this is tangent squared x times sine squared x.
How come the cosine squared x didn't go to both?
Because it's not adding or subtracting, it's multiplying. So if it was addition, good question. If it was addition, it goes to both. But if it's multiplication, I can separate it out. And I can put it with either one. They're both the same this time, but there could have been two things there. Yep.
Could you have simplify that one too?
Like the right side?
Yeah, make
Sure.
it sine instead.
Sure. As long as the left side equals the right, it doesn't matter.
So, for multiplication, the bottom can only go to one.
One, correct. Try it. See what you can do. All right, who can walk me through it? Go ahead, Mia.
Okay, so I started with the right side and I made it 1.
Okay.
Sine over times 1 over sine equals 1. And then I moved the cosecant up to sine x. And I moved the secant.
So it becomes sine when it goes to the top, right? So you've got sine of x times sine of x, and then secant goes to the top as?
Which becomes sine squared x plus cos squared x, which is equal to 1.
Good. Anybody do it differently? All right. So one thing I will tell you is make sure that if you're moving things that I know that that's what you're doing. So like if you want to draw me an arrow that moves it to the top, that's fine. But remember that the important thing here is the detail of the steps. You got to show me the steps that you're doing in order to get credit for this stuff. Whether it be homework or the quiz or the test, you need to show those steps. I know that you know what the left side's supposed to equal because it's got to equal the right side. It's like, here's the answer. Prove to me how you're getting there.
If we show that we're moving, let's say, cosecant to the top to sine, can we just go straight to sine squared?
Sure. As long as you're showing me that that's how you got it to the top, yes. Yeah.
I don't understand the whole putting it to the top.
So the long process is if I actually take secant and make it its reciprocal function, it becomes 1 over sine, right? And then I can do keep, change, flip, and it becomes sine squared x. So that you can do every time. The shortcut is anything that's a single term by itself. So this can't be like +1 and take part of it and move it to the top. It has to be by itself or being multiplied. Like it could have been 2 cosecant x or tangent cosecant x, and you can just move just the cosecant. But when you move a function to the bottom or to the top from wherever it is, like if you're reversing it, it becomes its reciprocal function. You just don't have to go through the keep, change, flip part.
So if there was a 2 connected to it.
So if it said sine of x to cosecant of x, you can move the cosecant and it becomes sine squared of x over 2. And then that's the same thing as like a half if you wanted to move that, but the same thing. It would be its reciprocal, right? Because 1/2 of, 2 would be 1/2. Anybody else do it differently? Did anybody try to find the least common denominator? Okay, that works too, right? Okay, try this one.
I brought the tangent above, so it's cotangent squared x. And then in the parentheses, I choose not to secant squared x. And then I put it as cosine squared x over sine squared x times 1 over cosine squared x, and it cancels out.
Good. Anybody do it differently? Yeah.
Well, I know that cotangent and tangent are reciprocal, so I kind of just cross them out. And then 1 plus tan squared x is
They're reciprocals, but if you multiply them together. So you can't just cross them out.
well, can you do like cosine over sine over sine over cosine?
So it would be cosine over sine, yeah. Over sine over cosine, right? But when you bring it to the top, it becomes cosine over sine. So you can't cross them out that way. If you're multiplying tangent and cotangent, then you can cancel them out. Does that make sense? But not if you're dividing. Oh, you want to check?
First of all, I changed the 1 plus tangent squared x to secant squared x.
Okay.
And then I did cosine x, like I did the top, so I did cosine x over sine x times 1 over cosine squared x. And then I got 1 over sine x times cosine x.
Okay.
On the top. And then I did the change flip. So I did 1 over sine times cosine.
So you made this cosine over sine.
Yeah.
Yeah, and then sine over cosine.
And then I got it.
And then you canceled out the signs, right?
Yeah.
Okay, and then 1 over cosine squared x, which is secant. That works too. Anybody else do it differently?
Well, I think
Oh wait, I wrote it wrong, right? No?
no, I didn't do it that way.
When I flipped it, I didn't flip this. This should have been cosine.
Yeah.
And then cosine cancels. This would be 1 over sine, which is cosecant. Nope, everybody else, either one of those? Okay. The last one said, again, verify sine of x over sine plus cosine equals tangent of x over 1 plus tangent. So this is one of those cases, like I can't take sine and move it to the top as its reciprocal function because it's part of the cosine. I can't move those, okay? And this time the left has the sine and the cosine, the right has the tangents. What are you going to mess with? The tangents, okay? So if what's one way you could do this?
Change the 1 plus tangent to secant.
So that's only if it's squared.
Oh.
What I can do is change tangent to sine over cosine, right? In the top, I can do sine over cosine. And in the bottom, 1 plus sine over cosine. If I wanted to make the bottom one fraction, what do I do? What does 1 become if I want to combine it with sine over cosine? Cosine over cosine, right? So this is sine x over cosine all over cosine x plus sine over cosine. With me so far?
Can we cross multiply?
Like from the beginning?
Yeah.
Sure. So then from here I can do keep change flip. This would be cosine x over sine cosine x plus sine x, and then those cancel, and I get sine x over cosine x plus sine x, which is the same thing as what's there, right? The order doesn't matter on addition or subtraction. It'd be the same. Well, the order does matter on subtraction as long as the sign goes with the right thing. So it does work. It might be a little bit more complicated to cross multiply, but you certainly can. So you could do sine of x times 1 plus tangent of x equals tangent of x times sine x plus cosine of x. I can make this sine of x plus sine x tangent x, sine of x plus sine of x over, or times cosine, no, sine over cosine. And then I'd get sine of x plus sine squared x over cosine. You can make that into 1 by multiplying by cosine. You can do the same thing over here, distribute. Make that sine of x over cosine times sine of x over cosine times cosine. And then this is sine squared x over cosine plus this would be sine. And then it would be the same thing. You'd have to multiply by cosine. So you can cross multiply. Can you separate them from the beginning? No, only if the numerator has an addition or subtraction can you separate it.
Because I did that and it would, like,
You can't, like, sine of x, what'd you do? Sine on both of them?
yeah, sine of the sine.
You can't split them. It's not, just because it works doesn't mean it's right. You can't split, like I can't say sine of x over sine of x plus sine of x over cosine of x. The fractions don't work that way. You can split a numerator, but they both have to have the same denominator, but you can't split a denominator like that. Because you can't go back that other way, right? That would be sine plus sine over sine cosine, which is different. All right, so your homework tonight is back to PDF. It's not on WebAssign. This is because you need to show your work and because obviously you know the answers already. So if you just did it on WebAssign, you just type your answers in. You need to make sure you're showing your steps on that PDF, okay?